This is the vernier caliper. The vernier caliper consists of two scales. We have the main scale and we have the subscale. This here is a lock. So if your vernier caliper would not open, make sure to open the lock here just a little bit, and then it can be slided back and forth. In today's lab, you will measure the length of the cylinder using the vernier caliper. Note that when you close the two jaws of the vernier caliper, there is a space in here. So always avoid to measure anything using this part of the vernier caliper, but instead we should use this sharp side. So in this case, I'm measuring the length of the cylinder using the vernier caliper. We can lock the vernier caliper so that if the cylinder falls down, the reading would not change. Now to take the reading, first take a look at the small zero of the subscale and ask yourself, where is this small zero in relation to the main scale? In this case, the zero lies before the 3.9 centimeter and after the 3.8 centimeter. So take your pen and write 3.8 because it's after the 3.8. Next, we need to find two divisions, one from the subscale and one from the main scale, that line up and form a straight line. Now, if you look carefully, you will find that the 6.4, if you look at the 6.4 of the small scale, you will find that it's lining up with the 7 of the main scale. So 6.4 from the subscale lines up with the main scale. So I'm going to add to this number 6.4. So my reading is 3.864 and the reading is in centimeters. You will repeat this measurement 5 times. Each time be sure to unlock the vernier caliper and place the cylinder again, lock and repeat. This device is called the micrometer. If you look at the micrometer, you'll find also two scales. One fixed scale, which is the one you can see here from 0, 5, and so on. And you have the moving scale, which has the numbers 0, 5, 10, 15, 20, and so on, up to 45. And then after the 45, you'll find the 0. So it has a total of 50 divisions. Let's, for example, take the reading of the diameter of the cylinder. Now, always, when you open the micrometer, you make sure that you open it using the big knob right here. And then you close it using the small knob until you hear these clicks. once you hear the clicks, this means that there is enough stress on the gears inside that allows you to take accurate reading. This here is a lock for the micrometer. So if you move it this way, now the micrometer is locked and it cannot move. Now to take the reading, first of all, again, we look at the main scale. But in this case, we need to decide how many divisions of the main scale we can see. Now in this case, if you look at the 5, we can see the 5 and we cannot see the 10. So if you count how many divisions, always keep in mind that anything below the line is half a division or half a millimeter. Anything above the line is 1 millimeter. So counting from here, 0, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and you can see the half right here. So this reading is 9.5 millimeter. So on the paper, I will write 9.5 millimeter plus. Now it is a little bit more than this number. So if you look at the small scale or rotary scale, we need to see which division of this scale lines up with this horizontal line on the micrometer. In this case, we have 1, 2. Okay, so 2. Now this 2, you divide it by 100, so we have 2 over 100 of a millimeter, because each one of the numbers on this rotary scale represents 0.01 millimeter or 1 over 100 of a millimeter. Okay, so our reading becomes 9.5 plus 0.02, which equals to 9.52 millimeter. So to take this reading, for example, you need to count how many millimeters you can see from the fixed scale in the beginning. In our case, if you count these, each one of these is 1 millimeter, but everything below the line is half a millimeter. So to count, you can do like this. This is 1/2, 1, 1.5, 2, 2.5, and so on. Now, what we can see from the horizontal scale in this example, even though we can see part of the 9.5, but we cannot see all of the 9.5. So the 9.5 is not visible. And how do I know this? Because the 0 did not reach the line. Okay? So we conclude that we can see here only 9 millimeters, 9.0 millimeters of this fixed scale. So here are the 9. This is 5, 6, 7, 8, 9. The 9.5 is not visible. So to finish up our reading, we need to look at the rotary scale and ask yourself which number is the closest or the one that lines up with the horizontal line. In my case, here is 40, this is 40, 45, 46, and 47. But each one of these is 0.01 of a millimeter. So when we say that this is 47, this means we have to add 47 over 100 of a millimeter. So my reading becomes 9.0 plus 0.47, which is 9.47 millimeter.